Each speaker, each speaker will speak for around 30 minutes. The last two speakers will be together, but for the majority, it will be 30 minutes for each speaker and then 20 minutes for a presentation and then around 10 minutes for Q&A sessions. So without further ado, let's get started with Ife introducing our first speaker.
All right, hello everyone. To start off this event, we have Mr. Yuhui Wang, and he's a financial analyst that graduated from Colorado with a bachelor's degree in chemistry and economics. He's currently a project leader at the Boston Consulting Group. Let's give a warm welcome to Mr. Yuhui Wang.
Hi, Yuhui. Thank you for the introduction. Can everyone hear me okay? If you can, maybe if you go to the reactions or something, just give me a thumbs up if you can hear me. Great. So as Ife mentioned, I'm currently a project leader with the Boston Consulting Group, which a little bit of background on BCG. So BCG is one of the three leading consulting firms in the world. We typically provide services to some of the largest companies in the world, if you will, working a lot with Fortune 500 companies, as well as a lot of really innovative businesses. So I've been with BCG now for about 3 years, currently in the New York office. The work that I focus on predominantly is what we call strategy consulting work. So a lot of times working very closely with Fortune 500 CEOs, CFOs, CSOs, chief sales officers, as well as kind of business unit heads to help them determine the strategies of their businesses, or to help them think through critical aspects of their business going forward. So spend a lot of time doing things like corporate strategy work, helping a business think through where they should invest over the next, call it 5 to 10 years. Also do a lot more sort of operations type of work, thinking through things like how to revamp a manufacturing organization, how to improve R&D efficiency, how to improve the way that a business might be going out to reach its customers. Including things like leveraging better technological and digital capabilities to reach customers. For me, I focus the bulk of my time in the healthcare practice at BCG, and specifically within the pharmaceuticals practice. So work a lot with some of the largest pharma companies in the world to help them with the things that I mentioned before. It's really rewarding job for the most part, where the bulk of the time that you spend is working with teams. And typically these teams consist of anywhere between 2 to 7 people who'd be reporting into me to work on these very tough problems for clients. Oftentimes we have the saying, like, if the clients weren't facing a big problem, they wouldn't be bringing us in. So it's a lot of problem solving skills, a lot of client communication skills, because what happens is clients may bring us in to solve one problem. We go in and realize the problem we're actually solving is a little bit different than the problem that they brought us in for, and you are oftentimes kind of trying to reposition yourself to solve the problem that they actually need to get solved. And it's a lot of teaming with people, understanding people's needs, making sure that your recommendations are aligned with the client's perspectives, making sure that you actually hear what they want. And deliver what's needed to help them get through the whatever they were facing at the time. So again, I've been with BCG for 3 years now. Prior to BCG, just a little bit of background, I was actually with a private equity investment company called SFW Capital Partners, based in Rye, New York. And happy to go into a little bit of detail there as well, if people are interested. And then prior to private equity, I was actually with a pharmaceutical business doing a lot of helping them through an IPO process and helping them with corporate strategy. And then prior to that was actually with a different consulting business up in Boston, working mostly with pharmaceutical businesses. And then I guess before that, I graduated from University of Chicago, bachelor's in chemistry and economics. And actually before that, I was basically in your spot. I grew up in Pittsburgh, Pennsylvania, went to school in Mount Lebanon, and spent quite a bit of time doing all kinds of work, like volunteering and things like that in the Pittsburgh area. So not that long ago, I was in your shoes as well. If I kind of talk a little bit about, I'll probably focus the bulk of my discussion on the consulting side of things, and if people are interested in hearing about the other side, the investment side, I'm happy to go into that as well when we get to the questions. So in terms of why I got into the industry. So going into college, I actually thought I wanted to be a chemistry professor. I really thought that I enjoyed chemistry. It was, in high school, I really enjoyed the subject, and I had a great chemistry teacher. And that really got me into, I competed a lot when I was in Pittsburgh, participated at like HIT chemistry competitions, organic chemistry competitions, things along those lines, and was really interested in that subject. So wanted to basically come up with a way to spend the rest of my career in chemistry. As I got into kind of college, I had taken AP chemistry. Mount Lebanon also offered organic chemistry, so I took organic chemistry already in high school. And when I got into college at U Chicago, I basically I skipped freshman chem, went into organic chemistry, which is second year chemistry at U Chicago. And that was when they start talking a lot about how you need to go into chemistry labs, you need to really, really sort of do a lot of research in order to position yourself well to go into grad school. And then at the same time, because I've like basically finished organic chemistry as a first year student or a freshman in college, I also got a chance to TA organic chemistry starting pretty early on. I TA'd organic chemistry for 3 years of college. So, I had a lot of opportunities that I think others didn't necessarily have, and got exposure to the chemistry side of things pretty early on, and started working in research labs. And that was when, I realized I was really not fit for working in a research lab. I didn't really enjoy spending time on a bench. I didn't really enjoy working inside of a lab setting. I think there's a lot of people that are cut out for those types of jobs. But what I did enjoy was the problem solving aspect. I spent a lot of time on the organic chemistry side of things, helping students think through the PCAs, which is kind of the easiest side of things, but also spent a lot of time when I was in the labs thinking through, how to take one molecule, what to do with it to get it to turn out into a different molecule, and conducting experiments and solving issues that we would see when we run the experiments. So that aspect that I really enjoyed. The other aspect that I realized I enjoyed is the people aspect. I actually really enjoyed being a teaching assistant, and also really enjoyed working with people. As I mentioned, whether it was working through problem sets or helping them kind of learn something that I really cared about, and did relatively well when I was in college on. So for me, it was basically important to find a career that would allow me to have that problem solving aspect on a daily basis, and also have a lot of working together in small teams in order to solve those problems. I've always believed that working in teams, you typically end up with the better answers than if you were just working on your own. So thinking about those two aspects, I kind of came across consulting as a career that really kind of allows you to do that. You really, as I mentioned, you're really kind of solving some of the biggest, toughest problems that an organization might be facing, and helping them come up with the best solutions for them that's out there. And a lot of times you're helping them think through some of the most cutting edge problems that they could be facing. So recently, for example, a lot of these businesses weren't prepared when COVID hit. So the bulk of the work that we did probably over the course of the last year was helping business think through what to do. When COVID started hitting, economy started shutting down, that has a lot of impacts on the business, not just from how do they help their workforce work in a remote setting, but also how do they think about what to do now with costs, what to do now with selling, because most businesses, unless you're a big tech company or a media company or something like that, really weren't positioned to kind of sell it in an economy that was became very remote, very digital. And especially in the pharma space, a lot of historically pharma companies have focused on what we call face-to-face sales, where you have a salesperson kind of knock on the door of the physician, try to sell them a product. That clearly was not going to work anymore in kind of a purely remote setting. A lot of physician offices were closed, or doctors were saying, we don't want you in our offices anymore. Or hospitals are saying, we don't want sales reps in the offices anymore. So it was a lot about helping them think through, what do they do now? How do you kind of transition from a purely face-to-face sales force into one that would be set up to do kind of Zoom calls or to do more remote engagements with physicians. The other thing, that we helped a lot of companies think through is how do you deal with manufacturing? Because what people realized was, it's hard to manufacture when the bulk of your workforce is remote. So helping them think through how they can get people back into a manufacturing setting safely. So those were some of the big problems that we were tackling, over the course of the last year for all kinds of businesses. But you also have, other types of problems that we try to solve for. Like a lot of times now, it's as the businesses are coming back from COVID, it's about helping them think through how do you position a business for growth going forward. And in terms of the day-to-day, what I'd say probably the bulk of the time is really spent on solving problems together as a team. So when I say team, what do I mean? Typically within a consulting engagement or project, the case team consists of what we call a managing director. So these are equity partners at BCG. So they own part of the business. And they're typically the ones who has the client relationships. They're the ones who have typically been in the business for 10, 20, on occasion 30 years, and have a lot of really, really strong background and understanding of a particular industry or a particular business or a particular sort of client setting. Then you typically have what could be a principal or a project leader that would be leading the day-to-day of a case. So for me, I'm a project leader. What we typically do is help the team think through kind of the day-to-day, what they should be working on, helping them think through like what problems they should be tackling. We do work a lot in like work streams, so people would be responsible for different aspects of the overall solution. And helping them basically figure out like what are the right things to be tackling on a day-to-day basis, and then also owning the client relationships as well. Typically not, you wouldn't be owning like the very senior relationships, but you'll typically have a lot of client counterparts that you would be responsible for. And then kind of with reporting into the PL, we typically have anywhere between 2 up to 10 max what we call associates or consultants. So associates are typically the folks that are joining straight out of undergrad. Consultants are either associates that have been with BCG for about 2 years or so, or those who joined us coming out of an MBA program. Or more recently, we also have MBAs that are joining us at that level. So typically that's kind of the case team structure. And in terms of, if I think a little bit about kind of the work streams, you could really be doing everything from talking to people in the market to understand, how experts think about a market. You could be running analysis on data, either the company's data or market data to help develop a solution. You could be, probably, as you'll see if you follow Amazon or some of these other businesses, you'll see they make fun of consultants for making slides. But a big part of what we do in the way that we communicate to our clients as well as internally is we make slides. And that's the way that we've come up with in terms of how best to communicate with the client teams and how best to tell the story that we want to tell and then put our recommendation to paper that's backed up. So that is kind of what the day-to-day looks like for the job. It's probably not doing it justice because every day looks different. I don't want you all to take away from this that all consultants do is writing slides all day. That's certainly a big aspect of what we do, but also not the only thing that we do. And it's very much a job that's focused on solving problems, very much a job that's focused on teaming with our clients, and very much a job that's focused on making sure that we are working with great people to tackle kind of these problems in a systematic manner. So I think I've spoken a lot. Kevin, I don't know, or I don't know if it's best to maybe open it up to questions. Again, I'm happy to answer questions from you all on either sort of consulting as an industry, or if anyone's interested in hearing a little bit about the private equity side. Also happy to talk a little bit about that. It's a very, very different job. So, questions? Feel free to go off mute. Don't all post questions at once. I think Xiaoyan has their hand up. Feel free to go off mute.
Yeah, could you talk more about the equity side?
The private equity side?
Yeah, could you talk more about it?
Of course. So the private equity side of things. So what does a private equity investor do? Private equity investors are focused on making investments in what we call kind of Main Street businesses, right? So you have some of the large private equity firms. So you can think of KKR, Blackstone, Apollo. These guys that are typically investing in businesses that are in the billions of dollars range, to what we call the lower middle market, or the kind of the smaller side of things, where these private equity firms, and the private equity firm that I was at was one of kind of these, maybe kind of a little bit more middle market, that was focused on investing in businesses that were typically worth anywhere between kind of $60 million to the largest investment that we did was about 800 million, I think, or so. But typically in kind of this tens to hundreds of millions of dollar range. And when we make an investment, usually what happens is our bread and butter, when I was an investor, was focused on businesses where founders, so people that started the businesses, make a decision to retire, or they make a decision that, hey, I have developed a product. However, I recognize that I need help in order to get this business to grow. So they'll typically look for outside investment, either through like a VC fund, if you believe like, this product has tremendous tremendous upside potential, but you need like capital to come in order to get it to that next stage. Or if you're more interested in selling your interest 100%, then typically a private equity fund would come in and kind of buy what we call majority shareholder, so over 50% ownership in the business. And what we would do is we would professionalize the business, if you will. So typically what you see is at a lot of these small companies that are founder owned, they typically don't have all of the functions that you would see at a big business. So they don't have a formal finance function. Their sales might not be very systematic. Kind of, they just take calls. Whenever somebody makes a call, they might not have a kind of formal marketing function, and we would help them build all of these. We would also help them, make a product better. So, for example, we had one business where they make 24-hour microscopes, real-time imaging that kind of go inside of the incubators. And their product was like really, really good, a unique product, but we needed to help them kind of think through how to make this product even better, how to sell more consumables, how to sell additional things on top of this great product that they had already developed. And that was a big part of what we did. And then what happens is these private equity firms, once you kind of make this kind of development process, right? You professionalize the business, which typically happens over the course of somewhere between 3 to 5 years or so. Upwards of 7 usually is probably the max that you'll see. The private equity firm will sell this business to either a different private equity firm or potentially to the market through an IPO process. And that's typically how private equity works. And when I was there, I was an associate, which meant that I was involved in the entire deal process. So if you think about a private equity firm making an acquisition, what happens is you start with due diligence, where an investment banker, basically somebody who's like if you know like real estate, right? It's basically like a broker who, on behalf of the seller, is saying, hands us a document, typically slides, that say, hey, we've got this great company, they do this thing, their financials look like this, they generate this much in terms of EBITDA, which is a proxy for the amount of cash the business actually spins out on an annual basis. They'll hand us this document. We, as the associate, will review this document and begin to do diligence on the market, competitive dynamics, the value proposition of this business, like i.e., why does this business exist? And then also look to understand other aspects about this business. What's been their customer retention? What has been customer trends? What did like their legal structure look like? What are the legal contracts with their biggest customers? Is there potential like flight risk of their biggest customers? Is there key man risk, i.e., if you think about Facebook, probably a few years ago, if the proverbial somebody got hit by a bus, do we have a risk that the business will go under? So you kind of go through all of these assessments, and then you make a decision on whether you want to make an investment or not. And typically, if you think about a deal process, the way it works is you have a partner who is usually like an equity partner in the fund itself, and then there's typically what we call a VP or principal that's leading the actual deal, and then you have associates. You can have anywhere between 1 to 2 associates actually working on the deal. And once you make an acquisition, the associates and the VPs are also involved in actually like working with the CEOs of the businesses to help them actually implement these strategies. So a lot of the time, I'd say probably like 60% of my time was spent on the deal process. Somewhere between 30 to maybe 35% was spent on working with these kind of the businesses that we already own, what we call portfolio companies, to help professionalize them. And then about 10% of my time is spent on like fund activities, which could be like anything like helping us raise the next fund, helping us do like annual reports or quarterly reports for our investors, things along those lines. So that's a little bit more on the private equity end. Happy to go into more detail. I see a question in the chat about how many hours do you work for a typical week? I assume I'll take this as answering for the consulting side. I think if I think about the consulting side of things, typically I would say 55 is a very good week. And probably on average, we're working somewhere between 60 to 65 hours. Now, if you are on a really busy case, or if you're on a really busy project where there's a lot of things going on, typically you might see like hours that start to get into more like the 80 range. But I would say usually those are more atypical than they are like the norm. Hopefully that answers the question, John. But if not, let me know. Any other questions from the group? What are the other major consulting firms? So the other major consulting firms. So usually we probably say McKinsey, Boston Consulting Group, BCG, Bain are 3 of the big strategy consulting firms, and then you also have the kind of the big four accounting firms that also typically have a consulting arm. So PwC has strategy and I think they also have Parthenon. And then you have KPMG with its consulting practice. Deloitte has its own consulting practice. And then who's the other one? Crap, I'm forgetting the other one. But typically, like the big four accounting firms usually all have consulting practices. And then you also have like specialized consulting players. Like you have Accenture, who's more focused on typically the IT side of things. You have smaller kind of either industry specific or like type of work specific businesses. Like you have LEK, you have Clearview, you have Putnam. There's also a business in Philly called Dynamics. And then there's just a bunch of like smaller businesses. So that's typically the list. What would be good undergraduate majors for consulting? I don't think there is a typical major by any stretch of the imagination. I think it's more about what do you bring to the table, and I think what we're really looking for are strong problem solvers. So you probably want to be in a situation where, or you want to position yourself to be able to demonstrate that you can solve problems, whether that's through your major or through outside clubs or activities. That's probably what I would focus on more. So usually what you have is a lot of these brand name universities or private universities will have like consulting clubs. Those are typically, regardless of what major you are in, those are actually like great avenues for you to demonstrate, hey, I actually care about this and I care about helping other people or other businesses kind of improve, and I care about working in small teams, I care about problem solving. And those clubs are great to get involved in. I'd say those are probably more important than what major you're in. Like we definitely have within consulting, I'd say the people I've interacted with have ranged everything from kind of English, literature type majors all the way to the hard sciences, like myself, or we have physicists or pre-med or all kinds of people in mathematics. So it really depends. Probably more the characteristics of being able to work well in a team, being able to solve problems that matter more. And then the other question that I got here is, once you discovered you didn't want to go with chemistry, what steps did you take to get where you are now? This is probably a too long of a question for me to answer in the time that I have. But I guess the short of it is, it took me basically a year to figure out what I wanted to do. Because there's a lot of options out there, right? Even if I didn't want to do chemistry, I probably could have gone and tried to become a doctor. I'd taken a lot of pre-med classes and probably would have been pretty easy to just get satisfied. I could have pushed through and just been like, okay, maybe I don't like chemistry, but I could go be a teacher in high school, for example. Maybe that could be an aspect that I could do. I could try to do other things, like go into finance, or I don't know, like go work at a chemicals company. And it was a lot about like exploring what's out there and like what I could potentially get into, to really understand what I wanted to do post college. I think there was a lot of pressure on me at that time to become a doctor, which I think is not entirely out of the realm of reason, but at the same time, I didn't think I really wanted to be a doctor, having seen kind of doctors around me, whether it was family, friends, or family. That really wasn't something that I was interested in. So had to basically figure out like where was my interest, where was my passion, and where would it make most sense to spend my time post college. That was probably not exactly the answer you wanted, AZ, but hopefully that sheds a little bit of light into it. All right, I think I've probably taken up more time than I was allotted. Thank you everyone for joining this and listening to me talk on your Saturday. Really appreciate it. And if you do have other questions, by the way, I'm happy to provide like my email address to Kevin, and maybe he can feel free to send it out to you guys if you want to email me any additional questions you have. Thank you again.
All right, thank you. Next up, we have, I believe, Hannah introducing our next speaker.
Yes. So I just want to thank Mr. Wang again for the insightful and wonderful information you shared with us. So with my pleasure, our next speaker is Mr. Nathan Grealish. So Mr. Nathan Grealish is the lead UX designer at UPMC Enterprises, and he also contributes much to the My UPMC website and mobile app. He graduated from Savannah College of Art and Design and Indiana University of Pennsylvania in graphic design.
Thank you so much. I am going to try share my screen here, but I think I need some stuff through my security here. Sorry, I didn't realize that at the beginning. Let me try one more time here. All right, hopefully you can see my screen. It should say UX, UI design and development. Oh, what is that? Well, let me first off by introduce myself. Thank you very much for the introduction, by the way. My name is Nathan Grealish. I'm a user experience and a UI interface designer and developer. This is better known as a UX designer. As you heard, I work for UPMC here in Pittsburgh, and I create, design, and develop their My UPMC app. So if you ever get into the healthcare industry, if you ever get into that, you can see the app and you can see the work that we've done as a team to put that into here. I hope you can all see what's going on here. I can't see if there are, here we go. Are you able to hear me?
Yep.
Okay, perfect. I can't see the rest of the screen here. So what is UX and UI? User experience, or UX, you can consider this the flow, the patterns, the mental state, the ease of use of a product. This is basically how you go from point A to point B through an experience. It is the overall experience. It takes a lot of research, a lot of surveys, studies, and it guides the interface to follow the best practices of an experience. So using surveys, using just discussions, interviews with customers, with users, we get the best case scenario for what has to happen. We'll get to in more detail on that in a minute. Now, the difference with that and the UI is the actual interface that you see. So it's the pixels, it's the colors, the fonts, anything that makes the design beautiful. If you go onto Google Music or YouTube Music, or if you go to Spotify, those are two different experiences. They share the same relative experience, but they have a different user interface, the UI. Spotify has the green colors, it has the large cover art, it has the specific fonts, where YouTube Music has the red colors and the blacks, and you can see the different UI there. It's the visual aspect. With a final UX that you get from the user experience side, the UI designer can make the experience not only feel great because of the good UX, but also look great too. If you are familiar with having a phone, if you have a phone in your hand, if you have an iPhone or if you have an Android phone, they spend a lot of money and a lot of resources trying to get their specific user interface and user experience down perfectly. You all might know that Apple really started the trend a long time ago with trying to be perfected for the use of the user, and they put the user first instead of the technology first. It's really great to see that. So a bit of the background on me. I grew up in Pittsburgh. I went to the Fox Chapel Area School District and graduated from the Fox Chapel High School. During my time living here, I just loved playing computer games and I loved doing graphics. I actually told my art teacher that I'd be coming for her job because I had such a fun time in her class. I had a lot of great experience there. I was probably, one of her top students just because of how much enthusiasm I had, how much love I had for this entire thing. And like I said, I was going to go to school and come back and take her job because I loved it there. And so that teaching, that experience in high school really made me decide to go to college for graphic arts. Now, way back whenever I went to school, like 15 years ago, I guess, we didn't have user experience as a mainstream thing yet. So I didn't really necessarily know that I was going into user experience. I just wanted to go for graphic arts. So I want to learn how to use Photoshop, Illustrator. I wanted to learn 3D modeling. I had all kinds of things in my head, and I knew that Savannah College of Art and Design was a place that I could go and do anything that I wanted and change my majors, whatever I needed to do. So I went to Savannah College of Art and Design for a while. I did things like graphic design. I did 3D modeling, animation. I did jewelry design. I did the whole gamut of what you could think of. After a little while of SCAD, I went to IUP to finish out the rest of my schooling. And while I was at IUP, I got hired to become a teacher in California. It's a very odd, long story. I could tell it if you'd like to. But what had happened was I was ready to get out there into the industry, and a friend of mine and I were working together for a while doing design online. And I decided, he said, hey, there's a job out here in California. You could become a vocational education teacher, and you could teach high school kids large format printing, silk screening, embroidery, apparel design, all kinds of stuff. It was great. I took the job and I worked there for 3 years. And during that 3 years, I had an awesome, awesome experience with all the kids there, and we were learning all together. And during this time, the design world was really changing. You might have heard the term design first, or even mobile responsive wasn't even a thing back then. This is all new in the last 10 to 15 years. After I did my school teaching, had fun teaching with my students, I moved over to a toy company called MGA Entertainment. Now, they make the Bratz dolls, who I'm not, a huge fan of, but they had a great experience. They had great designers. They had awesome illustrators. And I moved over there and I became strictly a UI designer. That was my title. It was called UIs, for user interface. And what I would do is I would actually design websites, and I would make them, look fancy, make them look different. If you've seen a parallax website before, we were one of the first companies to design a parallax website. That was a trend that happened for a few years, and finally it sort of got dumped a little bit here. But we made I forget what the toy line was, but for the toy line, we made it so that you can actually scroll through the website left and right, and it would look like you're walking through a house, and you can see the background moving differently than the foreground. Anyways, that was part of the UI. We didn't have any user experience training at that point. I worked at the MGA entertainment company for about 3 years or 4 years, and during that time that I was working there is when UX started to come around and be a thing. So while I was there, I had the ability to start learning what user experience meant. And from this moment on is where I really started to focus on more of the user experience and less of the design. I really liked to understand what users were going there for, what they were trying to do, what they were seeing, and how they'd get from point A to point B. From there, I went to Green Dot Bank, so financial institution, and I did all UX, very little UI. And I just started my development portion here, where development, I was coding some front end stuff, which I just started there. It was just very small. But with Green Dot Bank, this is where UX really blossomed for me. It really grew. And during these years, I think this is 2011 and 12 possibly. These years, the UX really became a real thing within the eye of many companies. And we were able to start changing the company where they would think product first, but we would actually talk to them and try to be user first. And this meant that when we got a request to design something, we'd be able to ask why, what's the purpose of this, and how does it serve the customer to be better? Because that was our job. That was my job, is to make everything better for the user. If it got worse, of course, then it was a worse experience, and we didn't want that to happen at all. After Green Dot Bank, I moved back to Pennsylvania, and I worked for True Image Interactive. It was a healthcare spinoff. So we were working on a prototype where you can actually talk to a virtual receptionist or a virtual concierge, if you will, and they would talk back to you in video form, video and voice. So you can actually ask a question. We would use machine learning, find out what the question said, asked, and then we'd give them the best answer. And out of those best answers, we'd have to show the correct video of the person answering you. Now, the hard part was that there's very little UI here. There's very little UX and UI total, because the whole purpose of this was to have a button where you recorded your voice asking a question, and then you'd get a video back, and that video would just say, hey, here's your answer. So where does the UX come in and where does the UI come in? That's the really hard part. Now, moving on from there, I was able to go to Wombat, which got acquired by Proofpoint, and I did UX and UI and development. So at this point, we did, I did a lot more development, a lot more front-end website development. So I was able to take my design from the design process all the way down into the actual development process. And what this did was help me understand, even more technically speaking, if it's possible what I wanted to do before we started doing it and having to spin our cycles. And then finally from there, I moved over to where I am now, to UPMC Enterprises, and I do, again, UX, UI, and development. And at this point, I have so much more under my belt. I'm able to do whatever is need to be done when it comes to actually designing and even developing if we need to. Let's see if I can move again. Here we go. So the job itself, a UX designer focuses on all aspects of our products. That means the initial concept. So whenever the leadership says, hey, we need to get something done, you hear about it at that point and you start asking questions. You go through the understanding of where the concept would fit into the entire system. So, for a quick example, what if we wanted to add a messaging portion of our app? How does that fit in there? Where does it go? And then eventually, how does it look? We would start researching the concept. So I would pull up a plan to research whatever that piece was. We'd have interviews, analysis, market research. We would do observations, A/B testing, whatever the actual research needed, or whatever the product needed, we'd do the research for. Once we actually got that research back, we were able to implement that best case scenario, that research that we got. And eventually, once we got it all on a whiteboard and all on just basically napkin drawings or tile drawings, things like that, then we can implement that we can focus on the UI. And that UI designer, or most of the time the UX and UI is the same person, we would take the style guide that we're given and we'd apply it to this wireframe that we've been given by UX, or that we've created out of UX. Once we've applied the style guide, including the fonts, colors, and components, we can get it into the review process and we continue testing on it. User experience testing is never done in a perfect environment. It's kind of strange to think that. Everything evolves over time, so does your app, so do the people. One example that I've been doing recently is we're trying to figure out how to do messaging within the MyUPMC app, but there's the traditional style email where you can send one email, you get one email back, which has recently conformed into, if you look at Gmail, it's more of a conversation, so that one email chain is all together, it's all threaded. And then you have the extreme where you can turn it into like a conversation, like your text messaging, rather than sending an email. So these are the three extremes on a baseline that we were able to research and find out what the best case was for that. So there's so many tools that you can look for as a UX designer. The couple that I have up here are just a few little trinkets of what I can show. But the UX designer has a large box of tools to come up with the right solution. The key component of getting a design right is listening to user feedback. That's what we do. It's a user experience job. We need to make sure that the user is having a good experience. That's as simple as I can put it. These diagrams here on the bottom left, this is a double diamond diagram. On the very left-hand side, we have the hypothesis. Oops, let me go back. The hypothesis, which is that idea you get from the leadership. And from there, you do this divergent portion of the diamond where you get to the center of the diamond and you're finding out really what's the question? Why are we asking this and why do we want something here? And eventually you come back to find out what the actual solution, what the actual problem is technically, and that's in the center of the diamond. Now from that actual problem, you diverge again and you find out some solutions. What's the best solutions to this thing? What can we do? And eventually you come back to the end of this double diamond and you say, okay, we have a solution for the initial problem. Then it says time continue, and that means you just keep redoing it as much as you can, as much as you have time allotted for. On the right-hand side, on this larger horizontal graph here, or vertical graph here, you have 4 cyclical phases for user experience. You've got the discover phase where you do field studies, user interviews. You can ask the stakeholders. You can do competitive testing. This means like going on to other sites and finding out what they're doing. And if I go back to that messaging example, I can go do competitive testing by using Outlook Explorer, or I can use Gmail or SparkMail or whatever email client you have. We can look at that sort of competitive testing that they've done. you go through this, again, they're circles, so they're cyclical. You can keep going and going and going as much as you have time allotted for. Figure out your discovery, you can actually start to explore what that looks like. So you can look at that, do a design review, persona buildings. Personas are your user types. So with UPMC, we have several different personas. If you look at, the older generation who have been introduced to phones in their last 5 to 10 years, you've got more of a medium generation, about where I am, where we're pretty heavy into tech. And you got the younger generation who are coming in now, who aren't necessarily so keen on what healthcare is, but they're very good with technology. So we've got these personas that you look into. You can look at prototype feedback settings. So we can actually make a prototype and we can give it to a user and have A/B testing and let them decide for themselves. After that, you do testing. And again, this is over and over and over again. And listening. You're going to listen. You're going to look at your analytics afterwards. Once you implement this, you just keep going back to it and say, hey, is this doing well? If it's not doing well, how do you fix it? If it is doing well, how do you make it better if you have time for it? Some of the skills that I've had to develop over the time are basically from left to right, from the beginning to the end is left to right, where you do a little bit of sketching. And by sketching, I just mean we're drawing boxes, literally. I have a thing called a dot grid book. It has grid, little dots that are in a grid, and you draw boxes to make it, to show your layout. Once you get that layout, you need to be pretty good at storytelling and communicating. So you can communicate your idea and your research and your design to the right people, to the designer, to the product owner, to the leadership. You need to be able to tell them the story of what's happening. And really, a user story is what we focus on. We want to know that they can go from point A to point B very easily and have a good user experience, as well as follow all the requirements. Some of the software that I use, Figma, I use on a daily basis. This is a brand new piece of software. I don't know if you've ever gotten into this, you probably know about Photoshop and Illustrator. I use those far less than Figma, but they're in there just for the little tweaks here and there. And then I use IntelliJ for my development. It's you can use any IDE, Atom, anything like that. You can even use Notepad if you wanted to, but those are just the tools that I've been using. Figma is really the biggest option for a UX designer, especially UI designer now these days, because of its capability that all the capabilities that it has. And I can get into that more if you'd like. So my day-to-day is basically talking with stakeholders. I'm going to try to talk a little faster. I think I'm only 1 or 2 slides away here. I'm talking with stakeholders about upcoming initiatives. So whatever that next thing is, we need to find out how we're going to put this in there and when. Planning the initiative with the product owners. So the product owners are just under leadership where they own that piece that's going through it and they make sure that it rides through as well on time. Creating a research plan based on the asks of the initiatives. That's making the research and having the plan to actually talk to people and find out what the best parts are. We need to design the flow or pattern based on the research. So depending on what it is, we need to actually design that flow and go through wireframing there. And then we need to apply the style guide to design. So from the wireframes, we put in our style and we make up mocks or mock drafts. And we present that final idea and tweaking that stuff for the leadership review. Once the leadership is okay with it, is good to go, then we present it to the engineering team. And then the design reviews, I do design reviews when the engineering team is done with that specific portion, whatever that ticket is. I can pull and find out what's going on and see if it looks all right. And if it does, and if it's working, then I can move it through. And there's just so much more to explain. It's incredible what we need to do day to day. The bottom line is that UX is very powerful. As I say here, helping people every day with making their lives easier in your product. So depending on your product, depending on what you do, user experience is what helps that product keep that retention of the users who love your product, and it makes it easier for new people to come on board. So user experience is really one of the most powerful things in a company these days. So I do have 9 minutes left. I was hoping to have a little more time for questions, but if there are any questions, you can go ahead and just shout them out on the microphone, or I have my chat open here and I can answer them from there as well. This also didn't update. I was hoping to have my email in there, but it's not. I'll put my email up there for you. So yeah, if you have any, there it is. If you have any questions, let me know. I'd be available to answer them for you. I have one here. What undergraduate majors prepared us for UI UX design career? So for these days, which I didn't have when I was back when I went to college, you have what's called human-computer interaction. If you look for HCI programs, they're usually in technological schools. You know, I think CMU has a really good HCI. Pitt probably has a really good HCI program. And that's really where you want to start looking at, is how human-computer interaction is literally how do humans interact with computers, and UX is the glue that holds that all together. I think that's your best start to go into there, or you can look into just design. You can start in design in UX, or I'm sorry, in UI. If you go into design and you like to do more of the illustrations and more of the actual design, you can start there and move your way up like I did. It's pretty simple to walk in once you have that designing under your belt. Another question is, how much development or coding do I actually do? And also if I learned it in college or after. That's a great question. It depends on the cycle of of our progress right now. So I could say that right now I do about 50-50 coding and designing for my company right now. Depending on the company and depending on the ask, you know, when I interviewed for UPMC, I interviewed specifically because they knew that I could do development and that I could help out there. Now, if you interview for another company who has developers who want to do that and who are looking for you for just UX or UI, you don't have to know anything about coding or development. It's just a really nice to have. It's a really good bonus because you can understand that your design, how it transforms into the actual tech. You know, there could be some things that are technically infeasible just because of the amount of time that they're allotted to actually make this thing. So that's how it sort of gets into that. And the second part of that question is, I learned after college. So I learned on the job, and I taught myself everything. I started with when I was at MGA Entertainment, I had a personal thing that I wanted to do. I knew the design for it, but I didn't know how to develop it, and I didn't want to ask anybody else. So what's the best way to get it done in your basic form is that you do it yourself. So I started off learning HTML and PHP, and I got some of that stuff done. Then technology evolved, and now I'm doing more Angular, which I'll talk about here in just a second. And the next question is, what coding language do you use? And that depends on the platform. So we have we have a web platform, and on our web platform we use Angular. Angular uses what's called TypeScript, which is a superscript of JavaScript. And you know, there's a lot of languages inside of that, but the platform is Angular, and it helps out with your development because you can make things like components that are reusable and they're redesignable on the fly. And if you just know a little bit of CSS, HTML and CSS, then those are the two basics for web as well. You can actually just make a website literally with Notepad using HTML and CSS, the little that you might have to know, and you'll have a website. It might not be served. You have to put it onto a server and to see everybody else, to have everybody else see it, but that's still a thing that you can do. For iOS and for Android, of course, you use Java right now, and there's other things within Java, like Kotlin, Gradle, things that are, you know, sub languages that you can use to make it easier on yourself. And then with iOS, I think it used to be Swift, and they're changing it now, and I'm not sure what the next language is for iOS, but that'll be something that I look into because I'm very interested in it. When it comes to CSS and HTML back on the website, Angular makes it a lot easier so that you can actually have components that you can write just like HTML, but it's not traditional HTML, so it's a lot more powerful. And then you can add the JavaScript into the HTML now to make it do things like be more dynamic. And then with CSS, traditional CSS, you took a lot to write a traditional CSS, but now we have what's called SCSS or less or Sass. They're all the superscripts of CSS that make it so much easier, where you can have variables, you can have actual methods or things that you can actually use inside of the CSS. And then thank you for these questions, by the way, guys. This is great. The next question is, what is your research method? Many years ago, I joined research to track human eye movements on a UI page to see how they catch buttons and charts and etc. That's one of the research methods. That's something we can do. And that happens after you already have a design out. So if I go back to, this might be a little clunky, but I'll go back to this design. Yeah, here we go. You see how these are all cyclical. They're all cycles, and you have to do them over and over and over again. So the cycle that you were probably in with this example that you're tracking human eye, the eye movements, is probably in this test phase. So they already had a design. They had something that they wanted you to look at to make sure that what we call a heat map of where your eyes, or where it could be even your mouse, where your mouse moves or clicks. and we can actually see more emotionally of what you're thinking about while this is happening, because sometimes an interview is very intimidating, and you're talking one-on-one to somebody like me, and I'm supposed to tell me anything you think. And if you hate it, if you really hate what's going on and you can't stand it, sometimes it's really hard for you to communicate. So it's really hard to bring that out. So a test like you did there with tracking eye movements really helps out, because there's no bias in that section there. But there's not just a single research method. There's dozens of research methods. It all depends. You can see these this list here, methods on the left-hand side. These are all research methods that I've had to use at one point or another, but it really depends on what the actual project is. And I hope that answers your questions as well. And I got one more here. Will those UX UI boot camps, career certificates, good enough to help land on a UI UX job? You know what? If those boot camps are really great, those career certificates, I haven't really seen used very much, but they are really good to pad your resume. And you can definitely land an intern. An intern. You can definitely land what are called a junior UX design role, I guess you could call it. But you could definitely step into a beginning UX career with those things. Again, it depends on the company, it depends on what they're looking for. But if you find a junior role that looks like you can handle everything, I'm sure you all know, a lot of these job postings are saying like, you need 15 years of experience, but I want you to be junior level, and I need you to be able to do coding and UI and product development and et cetera, et cetera. And like, well, this is for a junior level. I don't understand how you need this. But my advice to you is to apply anyways. And if they like what they see, then all the better, right? But yeah, those boot camps and career certificates will help get you through that. But yeah, thank you for all those questions. It is 3 o'clock on my clock here. I can answer probably one more question. I don't know if you'd like to move on there. Yeah, it seems like it's it for me. Thank you so much, everybody.
Okay, thank you, Mr. Grealish, for the wonderful slideshow you presented for us. And if anyone still has any questions, then please reach out to him. I think you had like your email on the slide, right?
I did, yes, and I'll put it into the chat for everybody as well.
Yes, that'd be great. So Kevin will introduce our next speaker.
All right, so next it's going to be a little different from the previous 2 speakers. We have 2 speakers with similar jobs at the same, so they're going to be speaking at the same time. First, Professor Ying is an associate professor of biostatistics at the University of Pittsburgh. She received her PhD in biostatistics from the University of Michigan and a bachelor's degree in mathematics from Nanjing University. Next is Professor Lin, who is a research professor of biostatistics at the University of Pittsburgh. She received her PhD in biology from the University of Michigan and a PhD in biostatistics from the University of Pittsburgh. So please give a warm welcome to these 2 while they explain their careers.
Hello, everybody. Yeah, nice to meet all the interested participants here. So I'm going to share my screen, and me and Dr. Ling will alternate talking about this statistics related career. Okay, let me see whether I can share my screen.
Thanks, Ying.
Sure. All right, let me make sure. Okay. Can you guys see our screen, my screen?
Yeah, can you change it to like
Yeah.
presentation mode?
Absolutely. Let me see. Okay, maybe view. So this one doesn't. Is it good enough now?
Yep, that's good.
All right. So I guess our focus is me and Dr. Ling are going to share our experience from being a biostatistician. And I'll let Dr. Ling go first.
Hi, nice to meet everybody here. So I actually started as a biologist. I have my bachelor's and PhD degree in biology, and I think I got my PhD degree in biology in 2001, and most of you are probably not born yet. So it was interesting. It's very exciting field, but it's also a very, in a sense, for personal life point of view, it's kind of a very competitive and hard field to do. And after I graduated, and I have basically decided that I want to switch my field, and a lot of people have asked me why I have decided to do that. Well, mostly for personal reasons. So if you are a biologist, you need to be in the lab a lot of times, and you have to do your work in the lab. And it's a very competitive field that, especially if you're working in the academia, there are a lot of students, postdocs, and however, there are much less positions in terms of PIs, tenure track faculties, that type of things. And as a statistician, biostatistician, as we move on, talking about it later on, what attracts me most is that I still get to work with, in the context of biology in the medical field, and it's still very exciting getting involved in all those important projects, but from a different perspective. And I get to work pretty much where I want. I can work in the office, I can work at home. So in that sense, it's fairly flexible. And the job market, as you will see later on in this presentation, is comparing to the pure biology field, is much wider. And then so that's honestly the most attractive feature of this field for me. So that's why I switched gear to biostatistics. So I have been a research track faculty since 2007. Research track meaning I focused not on the methodology research rather than the collaboration of the application part of the statistics, and help people with their projects, analyze data, help design a study, help getting the proposal in. And my I want to say this is 2000, over almost 15 years, well, over 15 years experience mostly are with cancer research. I've worked with other fields in the medical fields, but a lot of my collaborations are in cancer research, clinical trials, population studies, basic science, biomarker development. So if you are interested in any of that, maybe you could reach out. I'll be happy to talk to you. Now, Ying.
Sure, thank you. Yeah. All right, so I have a little bit different background. Maybe my background is kind of more traditional to go to this field. So I studied mathematics back in undergraduate. So I studied mathematics, specifically computational mathematics in Nanjing University as an undergrad. And then I came to United States studying math as well in a PhD program at Indiana University. So at that time, I learned a few statistics courses. Back in that time, the Department of Mathematics, both in Nanjing University and Indiana University, have a special kind of field in statistics. So it's not a department, but it's a program. So very naturally, we have been introduced to different kinds of statistics courses, such as like some fundamental ones, for example, like introduction to probability, statistic inference, and several data analysis courses. So that's how I got to know statistics. Then I found this is more interesting compared to pure math. So I decided to pursue a degree in statistics. At that time, I was actually admitted into both statistics and biostatistics departments, both at University of Michigan. So Dr. Ling and I were both trained at Michigan, and she was in biology, I was in biostats, although we didn't know each other until when we came here. And I honestly, at that time, I don't know anything about biostatistics. I know is, okay, this is within School of Public Health. That means this particular degree or program deals with more, I thought is biology related, but more accurately, it's more like public health or biomedicine related research problems. So then I studied in biostatistics and graduated in 2010. And my first job was in a pharmaceutical company. So I was working at Eli Lilly and Company. So this is basically a drug development company. So at there, I am called a research scientist, and my daily job focused on helping developing clinical trials. You know that when we investigate or develop a drug compound, we run a lot of clinical studies from early phase to late phase to study both the efficacy and safety of a particular molecule. And as a statistician, my role is helping design the study. For example, how many sample size we need to include for this study. And then how do we, randomize the treatment, different treatments to our study participants. And how do we collect data? What kind of data should we collect? And how do we, design our sort of like some data collection forms or even questionnaires to guarantee that we collect enough and informative information. And finally, very, very important, how do we analyze the data and interpret the data to help the drug development in making decisions such as, is this drug effective, and is the drug safe? So to move to later phase or move to submission. And you know that very recently, a very big news is Biogen had the first AD Alzheimer's disease drug being approved. This is like over the last 2 decades of investigating, a lot of money and resources in, let me admit, in this AD related research. So I actually worked on the AD Alzheimer's disease a little bit as well, although mostly in diabetes. So that was my first job. I worked there for a little bit over 3 years. Then I came to Pittsburgh in 2013. So I joined the same department as Dr. Ling. And they have different focuses of the faculty positions in biostatistics. So this is also like another very kind of popular job or career for a biostatistician. So to work in an institute or university. So my job includes doing methodology research, like basically developing new theory and methods in statistics, and also collaborative research. And I worked in cancer area as well. In addition, I work in mental health or psychiatric disorders. And besides that, because this is like a department, we have both masters and doctoral students, so I teach courses for them too. So that's my current job. Okay, so I guess I'm gonna let Dr. Ling to continue.
Yeah.
Yeah.
All right. So, Ying, I think this is your slides. Do you want to talk about it, or want me to?
I think you can talk about. Okay, I can talk about it. That's right. Okay, next one is okay. Yeah. So when we mention this title, we say career as a statistician or biostatistician. A lot of times people may ask, what are the differences? In fact, when I was applying for grad school in 2005, I don't know exactly differences between them. And people even ask me when they're trying to think their children's like career, does biostatistics more meaning biology related or statistics related? So I will first talk about statistics. So you know that statistics is a quantitative major. So we say this is a science concern with developing and studying methods for collect data, analyzing data, and also importantly, interpreting the data and presenting the data. So it has a lot to do with data, and it has a lot to do with quantitative skills because we need to develop methods and we need to apply methods. So, but very different from mathematics. This is a highly interdisciplinary field. So we always motivated by real research problems. So not like math, right? Sometimes you work on the problems really for fun. Has some applications, but not always. But statistics, usually the methods we develop or the theories behind the method are motivated by real science questions. And I said here, usually they have applications in virtually all scientific fields. So all kinds of, so I would say statistics is a broad term, and the application out of it, not only directly to the public health or biomedicine, it can be any fields such as, economics, finance, and sometimes social work, and even, more like engineering. So it has very broad applications. However, the theory and methods underneath it, we share very similar or same methods and theory, no matter whether we focus on bio or non-bio statistics fields. I guess, yeah, Dr. Ling will give you more about this specific for biostatistics.
Yeah, so yeah, there's like many universities have both biostat and stat department. And you will find that many of the classes are actually overlapping because that's the basic what you need to do. Biostatistics, in a sense, is more emphasized on the application to a medical field, or sometimes it's biology. But I think biology sometimes is applying math are more into the modeling, the specific biology model, molecular modeling. But at this point, the biostatistics, for example, in our department, is more into the application to the medical field, into public health. And a lot of our students graduated going on to pharmaceutical companies. And also biostatisticians are, so like for me, my regular day-to-day work involves a lot of collaboration, talking to people to understand what exactly they are trying to do and trying to interpret their question into a quantitative way and try to solve their problem, try to predict or try to analyze data. So I think that's probably what the biggest difference is, that we are more focused on the medical and public health. Although there are a lot of crossfield, we have a lot of statistical department faculties who are also working on the same projects as what we do, and we also have some of our faculties reached out to other fields. So it's a very very intertwined two fields together, I have to say. But I think for statistical department, I think there are more heavily emphasizing on the mathematical theory of end of this.
Yeah, and yeah, I think what Dr. Lin just said is very accurate. So as a biostatistician or in biostatistics, we have a lot more responsibilities in interdisciplinary collaboration, regardless what kind of track we are in. So our collaborators are usually from like health science related. So like School of Medicine and other schools in health sciences, and sometimes basic scientists such as biologists. And yeah, so we are more, I would say we are more applied focused, although we also have a lot theoretical or methodology development as well. And
yeah, it's almost like we're more specialized subfield from statistic. Is like more recently evolved out, more focused subset of the statistics in a sense.
right. And as Dr. Lin said, a lot of the fundamental or core courses are quite shared between the two departments. Sometimes we cross-listed courses between the departments. And of course, there are some more special, topics in the biostatistics focused program compared to statistics. And usually in a lot of like examples or real data projects here in biostatistics are mostly or almost all from biomedicine or public health related research. So now most of the universities, the biostatistics program or department is within School of Public Health. Okay, that's like not the School of Medicine, School of Public Health, but it is also belonging to the bigger umbrella of health sciences. And as of now, majority of School of Public Health for biostatistics do not have undergraduate degree. So that's also a difference. Statistics, usually it has an undergraduate degree. So we usually start from master degree and then PhD degree. So for our students, a lot of them have a bachelor degree from statistics or like mathematics or some other field. We will talk about that later. But I think our university, our school is now trying to developing a bachelor's degree, more general, called in public health. So BSPH.
Yeah, I think there's a more general field instead of like how quantitative that would be is another question. Yes.
Okay, maybe I can talk a little bit about this page. So what are kind of the job demands in statistics and biostatistics? So I searched up a little bit this week. So by this 2020 US News and World Report's job ranking, it ranks statistician as the #1 best business job. I don't know how many total business jobs are there. And it ranked #6 among the top 100 best jobs across all categories. And also #6, the STEM jobs. So this is like how people rank this statistics job as a profession. And this is a high demanding area and is growing very, very fast. So the Bureau of Labor Statistics has a prediction that the employment growth in biostatistician will be much faster than average by 34%. And by 2024, we will have more than 10,000 statistical positions nationwide. And actually, when I was teaching in biostats, I have seen a lot of students, they are actually transferring from other fields, like Dr. Ling's situation. I have seen those students who already had a master or PhD degree in other fields, for example, biology, they would like to pursue a degree in biostatistics. And several reasons. One reason is we are very demanded and the job marketing is very promising, very good, so easy to get a job. And second is usually when they're doing their research, like in the lab or in a clinician's research lab, they found they need a lot of statistic support. They have to work with their data. So they need tools or methods to analyze the data. And they found statistics in general is very useful. So they want to pursue a degree in statistics. So we have seen that very often. So Yen, do you want to talk about our varieties of jobs?
Sure. So our graduates have been very successful in obtaining jobs, both at master level and PhD level. As what I have mentioned that a lot of our students, especially PhD level PhD students, they graduated and they obtained a job in a pharmaceutical company. Or biotech company. And then some other students were more into the life of, being a faculty in the university. There are different tracks in the university. For example, in our department, we have the tenure track, which Ying is on. So the tenure people, they are expected to teach methodology development and also some collaboration. So it's a pretty demanding role, but it's very rewarding. And then there are also like a research track like me, like we almost 100% of my salary support is from grants, what we call soft money. And so we collaborate with people, we help them with their study design, their statistical needs, their analysis type of thing. And then we solve problems, but we are not spending much time in terms of methodology development. It would be nice to have some time, but usually because our collaboration job is very demanding, so we have little time to do that, but that's the research track. And then there's teaching track. Teaching track is basically spending most of their time teaching multiple courses. This is similar to some of the statistical department, and they also have different tracks. I think they're more onto the tenure track and the teaching track because they have a lot of undergraduate classes. And there are educational institutes or research facilities. These are also places very similar to our to the universities, but they're not exactly university. For example, you could be working in a cancer center that is not affiliated with a university. So in a sense, we're doing similar work, but at different settings. And then a third big trend, big area we see our graduates go is to the government, like FDA, NIH, CDC, those type of places. These are more on the regulatory, like FDA is more on the regulatory type of thing. So they review the submitted studies. They have, they focus on to make sure the drugs that are to be approved has rigorous design, analytical property, and then they pass all these regulatory hoops and how they get to approved by FDA. And the NIH is somewhat different. It's almost like a university. It has different tracks. There are certain groups in NIH are mostly focused on the methodology research, and some of them are more on the collaboration with the NIH researchers. So in my mind, NIH is more like a university, and also there are hospitals, and a lot of these are research or teaching hospitals where you have a lot of research going on, but also there are things like other hospitals that we're basically have to have certain quantitative group to summarize data, organize data, and like for example, UPMC has its own statistical group, where, for example, if sometimes my interaction with them is that sometimes we're doing a population study and we want to get some data from them, but we cannot get to the individual level data, then they will either break the data or summarize the data to us, and then we try to make use of that. And there are that type of groups too. And also what we didn't put down there is like there are health insurance companies like Highmark, UPMC, that they also have statistical group that needs a lot of statisticians. So I would say all these places have, like first, even in the university, in this research institute, we have both PhD level and master level jobs. The PhD level jobs is more onto, not like we do some hands-on, but more onto overseeing and make sure that the study design, the analysis was done correctly. And the master is more the supporting role. Therefore, people are looking into different, so the focus of these, like we'll talk about it in terms of training and what kind of skills are needed, they're different. And different places will have different composition. For example, in the university, you will see more PhD level jobs than master level jobs. But for example, if you're going into like health insurance setting, there are more master level jobs than PhD level jobs, I would say.
Yeah, thank you, Yan. Yeah, when I was working in the pharma, statistician is actually a very big group compared to other cross functions. So we collaborate with almost everybody, including like regulatory people. So when we're doing submissions, after usually the late phase, statistician plays a very important role. So I think at Lilly at the time, we have a few hundreds of statisticians, both master level and PhD level. Of course, besides pharma, the industry can have other types, right, for the statistician job, like a biotech. So that's a little bit different. They are not really developing drugs. And sometimes they're developing, for example, assays or particular technologies that can be used for example, for diagnostics, like getting a diagnostic tool for testing, or can be used like a device, medical device. So related to medical fields, but not exactly the drugs. Or there's also a special thing called CRO company. So these are the companies, usually pharmaceuticals, will collaborate with, or we call outsource the job. And there are many statisticians working in such CRO companies. And of course, consulting is also we didn't list it here, but that's also another types of job. It's more like the role of the statisticians for the consulting job is like provide. Usually they need to be very experienced and thoughtful. They provide like the advice from the scratch of designing the study, and then exactly how to collect data and how to for different companies. So in short, we have a lot of different kinds of jobs. So the job market is very good. I think all the students graduated from our department, I didn't hear any who could not find a job after graduation.
Yeah, they pretty much are snatched up pretty quickly.
Yeah. Okay. What's like?
Okay. All right. So I guess I'll start this. Chime in if you just chime in anytime if you feel like. So what's it's like to be a statistician? It really depends on where you work. Okay. For example, as an example, before pandemic, I came into the office every day, and then I do a lot of time. I just design of the studies. For example, when people start trying to answer certain questions, they need to design a study. Not only clinical trials, even for animal studies, for lab studies. If you could do a better design, you're more efficiently using your resources. So that's a big chunk of it. And then in clinical trials, we don't exactly do data management, but we need to oversee. We need to know where data is coming from, what we are needing, and who's collecting them, whether there are many problems. Because, for example, I'm working on an international phase 3 trial currently, and so I need to make sure that what the data management team is doing will provide sufficient data for later on data analysis, and we need to develop the statistical analysis plan ahead of time and make sure that what I needed is all collected, is all in certain format, is all passing the regulatory guidelines. And that's the day-to-day life. And also, obviously, we do data analysis. We help people with publication. We do programming, and we do writing. So it's. I remember I asked my son. I said, "Do you want to be a statistician?" He's like, "Oh, that's so boring." I would think that. Well, it depends on. I feel like statistician is not just sitting there and counting numbers, or just it's actually a pretty dynamic type of job, because I gotta talk to people. I gotta try to understand different fields, different projects, and then it could be pretty exciting. It's not only number crunching that a lot of people view us as like we just crunched a number. That's not the case. And so on the other hand, we're also very flexible. For example, I could be working midnight at home, but if I have to do something during the day and just push my work to later at night, I could do that. I don't have to come to the office. I could pretty much work wherever I have internet and lab. So that's how my job is like. Okay, so other statisticians probably has different type of setting, depends on where they work. But overall, I just want to say I really don't feel like it's such a boring job. How about you?
Yeah. Even like when I was in pharmaceutical company, I was majorly in one therapeutic area, diabetes. So people may think, if you work in that area for like 10 years or more, how can you, not being bored? Actually, even the same compound, if you're developing different studies from, different phases, you encounter all different problems. So you cannot really have like a so-called a template that can work for all the studies. We always have different new problems from that specific study, which we haven't encountered before. So in short, it's definitely not a boring job. And especially nowadays, because of the advancement of the technologies, all kinds of large data, right? Big data, we all call big data, either from, like genomics. I don't know how much you know about genetic genomics, but about your own DNA, own chromosomes. We collect a lot of data or other data, like electronic medical records. That's also another big data. So in short, the job is not boring because we have always more new challenge problems. We have to face new types of data, and we need to develop new tools, both methodology-wise and also computational tools.
And it's certain sense is could be challenging because the new technologies are just coming out pretty much every day. New things are coming out. You have to keep up with not only the statistical methods, but also the new technologies. And so it's challenging. That is also it's fulfilling too, because you get a chance to get involved in some very exciting studies, and it changed the practice. You feel like you're part of the team that actually saved people's life.
That's exactly how usually the statisticians, especially working with farmer or working with biomedicine related fields, because the work they did really make a great impact, both on the populational level and individual level. So, and also it's challenging in the sense you cannot just use the same method or tool over years. For example, before, we don't have such a big data, but now usually we cannot use our own computer to do this analysis. We always need server to analyze huge data and run simulations. And the data is huge in terms of the size, both like number of patients, number of individuals, or each individual, how many data points they collect. It's very huge. And we will get to the difference between statisticians and data scientists later, shortly. Okay, maybe I can quickly talk about this page. How much does or do biostatistician jobs pay? I would think the salary pay is good, is decent, but if you think some other very high rewarding career or professions, such as computer scientists or some others like financial related, it is not as high as them. But still, this is like I Googled a few days ago. I think this is within a week or so. That's what it says from these places about the average salary for a biostatistician. Of course, it depends on the rank, like when you just finished.
I think you have the PhD and master lumped together here, right?
Yeah, this is more PhD and master lumped together. And this is also like not, it also depends on where you are. Like if you're in the East Coast or West Coast, you usually get more, right? But your cost of living is also more. And also depends on whether you're in industry or government or university. University in general pays a little bit less, but we do have, I would say, more benefit from like flexibility of the work, and also our usually the other benefits like health benefit and the retirement plan are usually better than the industry. And of course, if later on have children, universities sometimes always have benefit about the education for the children, especially in college education. So that's I think that's what we usually get. And I would say we're not that much intensive in working. I would say we mentioned that we have flexibility So we can do some work in the day and then make it up in the evening if we have to do something in the day. And compared to other very, very like fast changing field like CS, we're slower in that pace, even though it's still changing. So I would think it is a really balanced career. So fairly well paid and have some pressure, but not too much pressure.
But you don't get into biostatistical field just to be rich. You can see it's it's a decent field, but you don't get really you don't usually get really rich unless there are statisticians who started companies that are very successful, right?
Right. Yeah, that's like a different story. If you have
and that's a different story.
Yeah, consulting or other like personal businesses, that's different. Okay. Yeah, maybe Ying, you can talk about this page.
Okay, so education training skills. So it's a quantitative field. I mean, I came from a biologist field. I truly feel that, the disadvantage of not as quantitative as some of the other students. So I would think that quantitate like if you're good with math, if you have solid quantitative background, I think you have a good chance to do well in this field. As what Ying has mentioned, that basically this field require a professional degree, in like master or a PhD level degree, depending on where you are going. If you are more focusing on the programming, computing, and you're happy to be in a supporting role, a master degree is good. And if you want to be more on the like a leading part in either or want to do teaching or type of things, you need to have a PhD. Sometimes you see statisticians with other backgrounds like epidemiology. Epidemiology is a field that uses a lot of statistics. So a lot of epidemiologists could do some statistical analysis. Well, usually they should be able to do some, at least some at more routine type of thing. And then bioinformatics is a relatively new field that deals with genomic, proteome, that high dimensional biological field, like these new technologies that are needing for a lot of computing analysis. So some people are more focusing on that. And also it has to do with annotating. It's more, I would think that bioinformatics field is closer to biology than us. So because you need to understand it, you need to understand the database where these things are and terminology. And the data science, it's a new field. I can't say I mean, I have a sense, but I think Ying, you probably has better sense of how this data science umbrella is there and how is that related to all these different.
Maybe not better, but I've prepared a slide.
So Ying will talk about that, and you will see that this is becoming a very popular, and now you can and is at bachelor level there are data science bachelor degrees in many universities, and data science also is a highly demanding. Data scientist is very is a very highly demanded, and they can get a very good jobs. And then in general, if like well, this is secondhand knowledge because a student of mine was who worked with me for a bit and then went out for a job, and she wanted to get into this data scientist field, and she realized that for the same company, if you have say master level statistician job and a master level data scientist job, the data scientist job is it has a slightly higher pay than the statistician job. But in terms of exactly what like what is required and what exactly they do different from the statistics, I think I'm going to refer that to Ying. For like what I said, quantitative background is important, and the computing and programming skill is also important, especially if you are getting a master's degree and trying to get into a master level job, which is a lot of time doing a lot of computing programming support for the PhD level statisticians. I would say, because we are a very applied field, so you don't sit there and do derivations all by yourself. We go out, we collaborate with people, we deal with real data, we deal with real world problems. So people skill is important. You need to, so a big chunk of my job is trying to translate what the scientists want to solve into quantify that into problems that we could solve by statistics. So I would say people skill is also very important in your job. Anything that?
Yeah, definitely you covered very well, Yan. Yeah, as I said, if you really have a strong quantitative skill, like if you're good at math, that really helps. Yeah, I think when I was transferring, I shouldn't transferring, but I started to study biostatistics. Thus, like core courses, these quantitative ones are kind of not hard for me because I was mathematically trained. So when I handle the exams, these are sort of more, I would say, more straightforward because we have the mathematic thinking habit already developed. So the math part is quite important, but it's also very different from math. So we do really have a lot of more applied skills, more programming skills. So we have to deal with the data. So you cannot just write formulas and equations. So we have to use software or yourself develop tool to analyze the data. We have a very like statistical focused software called R. So the single letter R, which has been used a lot. Of course, many people use SAS. And more recently, I think a lot of people, including myself and my students, are using Python because we are handling very big data and doing also some data scientist related job like machine learning. So yeah, okay, maybe now data science versus statistics. And this definitely statistics is very well developed, so it has long histories. Data science is more new, right? So I would say there's a great deal of overlap between these two fields. And both deal with data. While data science may deal with more specifically big data or bigger data, even though we deal with big data too. So statistics, they focus more on like rigorous methods and analysis that they can give reliable conclusions for the data. And so they focus more like the methodology part or the rigorous application part to analyze the data and then interpret the data. While data science, I think is more direct. They deal with the data directly. And you can see data science is also a very interdisciplinary field. So you can find that in computer science, and you can find that from mathematics, statistics. And it requires really good skill of hands-on using computation tools to also analyze the data. And they're less focused on how solid or what is exactly theory or method on the background of analyzing the data. They're more like evaluating, for example, if you're doing prediction, how accurate your prediction performance is, rather than whether these assumptions of the model have been met when you're using a particular model to analyze your data. So we're doing a lot of this now as well, because the needs and also the high dimensional structure of the data. So another term related is called machine learning or artificial intelligence. Well, you can think that if you don't even know much, you can think is you try to let the machine learn from your data, learn the pattern or learn the useful I would say useful signals from your data, so that you can make some findings from your data to help answer your scientific questions. So I would say these two are very related, but with different focuses. Okay, one is more methodology or more statistics or mathematics related. The other is more computing and data direct.
Yeah, and now you see more, like you would see more stat or biostat department has data science in their either title, or they have their track, data science track, which is, so that is also an evidence of how closely these two fields are related.
Yeah, and lots of if you see a lots of programs now have, for example, I think CMU is called Statistics and Data Science. So they have professors that are very skilled in computer science in their department or machine learning focused. So, okay, I think we're leaving a few minutes for the questions. So this is our info, and this is our building, the school public house. We are on the 7th floor. You can find us if you need specific, help with specific questions. As of now, we don't have an undergrad degree in biostats, but it does have stats undergrad degree. And you can, if you are closing to apply for colleges, you can easily find like the top ranked statistics or biostatistics programs from the web. Thank you.
Yep. Thank you, and let us know if you have any questions.
Okay, I see the chat. What's the most exciting part of your job, and what's the most challenging part? If it's a industry job, what's the most exciting part? Okay, maybe I talk about the industry job because I was there. I would say the industry job, most exciting part is through collaboration. So statistics is usually a supporting role. So because you're not the physicians who are dealing with patients on the front line, you are more like helping them to make the best out of their study. So I would say the most exciting part is you're using your skill and to help them answer or give recommendation of a scientific question or scientific research. So you're more like in a supporting role, but however, they depend on you a lot, because sometimes a bad design study would ruin the entire study. You cannot really answer the scientific questions, or a bad analysis would also make incorrect conclusions. Maybe you can talk about others challenge or in general.
So in my experience, well, the exciting part is that I get to be involved in a lot of studies that I personally found very interesting conceptually, although I'm not exactly in the field, but when people explain that to me, I found that very, a lot of the concepts, a lot of things people are working on very, it's very exciting and very interesting. And I was very happy to be part of the team. And also it's exciting. I'm very happy. Sometimes I demonstrated something using my statistic skill to say, see, this is why, this is that, and you find some subgroup of things that really makes sense, but you get to use your own skill to do it, and people were like, oh wow, that's great. But the challenging part is also, as a statistician, you understand how the data work, and especially nowadays there's so many data, and people are just analyzing it to death and not considering what they're doing, and they think they're doing statistics, they're not. And then when you're trying to point that out, the response is not really satisfying in the sense that so that is a challenging part in my experience. And also another challenge is that is also the excited part of it is there are so many new things to learn, so many of them. You gotta be on your toe all the time.
Yeah, I would concur that one of the challenges, yeah, it's an emerging field, lots of new things. You cannot just learn from the book and then you are good for the rest of the career or rest of a few years. It's changing all the time, so we always learn new things, and we always trying to develop new courses for our students as well. And sometimes the faculty need to learn themselves to be able to teach that too. So yeah, thank you. Any other questions? Anything, for Yang and me, interested in both our husbands. I mean, we are all kind of statisticians. Maybe such a boring family. But I found that it's interesting when we look at our student portfolios or our faculty portfolio. In biostats, a lot of females. So that's what we observe, both from the student's point of view or faculty point of view. Because usually when I was in math department, we have much fewer female students, a lot smaller compared to in biostatistics. I think because the quantitative challenge is less, and it also, it is also exciting, like a STEM related, and it requires very good people skill to communicate well with all kinds of collaborators. Do you need any computer? Oh yeah, of course. So as I mentioned, we need to analyze the data daily, really. So it's not like we're developing methods from the vacuum. So we need a lot of computing skills. I was in computational math. So at that time we learned like C or Fortran even, very kind of outdated languages. But I think the training of how we, the data structure and how all these computing logics are useful later for different kinds of computing languages. I think I mentioned we use several more predominantly. We have some like very user-friendly programs, softwares, right? Yeah. So even some interface, very interactive. So you don't really write line by line codes, but you can do some click through for, that is more for.
That's more for a statistician. You do need to have a good programming skill, but you get training in your when you're in your when you're students, when you're in your master program or PhD program usually. So you coming in, like when we are looking at our students, we do not expect to have a very strong programming skill.
It's
right?
not
It's not
required,
required. It's not.
but
required.
if you already have it, it will definitely help you.
Yeah, it will be very helpful. All right, I think we already passed the time slot that we're allotted. And if you have any questions, just reach out to us with our emails on the slides, and we'll be happy to answer any of your questions.
Yeah, I just also want to thank our organizer for having us here. And I think, yeah, we're glad to see a lot of young students are interested in exploring this field.
Yep. Thank you guys so much. I just also wanted to thank everyone that attended today, especially our speakers, for just taking the time to attend our event. I hope everybody learned something new today, and I hope all of the young students have a better idea of what they may want to do in the future. So we will have one last career exploration event next week at the same time. And we'll have a veterinarian, FANG UX designer, and a cardiologist. So once again, thank you all for attending today, and I hope you all have a good rest of your day. And also to all the fathers out there, I'd like to wish you all a happy, an early happy Father's Day. So thank you all.
Thank you
Thank you.
and bye.